Hi, hello, vanakkam, and welcome back to yet another interesting episode on your favorite Little Slaw YouTube channel. So today in this video, we're going to see about the differences between performance testing, performance engineering, and the site reliability engineering. Although these three look more closely like they are related to each other very closely, but still there are few differences, and we're going to discuss about various topics, various aspects on these three topics, because most of us, we all know, we do some tasks of performance testing, some of the process of performance engineering, some of the process of SRE, the site reliability engineering. So if you know which tasks you are already doing and which one should you improve, that will help you to navigate to the right career path, and it will help you to have a good growth in your career. So that's the reason we're going to discuss this part in this video. And the topics which we are going to discuss are the primary focus, the objective, the key activities, the approach of all these three jobs, and then what are the tools we are going to use. So when I'm talking about the tools, I will explain you what are the tools that we're using in each of these job areas, and what are the trainings we as a Little Slaw are providing. So that will help you to understand more about these jobs and the trainings that we are giving, and then what is the team's involvement, and what are the responsibility of yourself when you're working on each of these jobs, and then when implemented, what are all the aspects that you're going to cover, and what are the metrics that you're going to measure, and what is the outcome of your job, and what is the key goal of your career, and what are the automation opportunities you have, and finally the end result that you're going to have as part of these three career path. So firstly, let me start with the primary focus. So what is the primary focus of all these three jobs, or all these three career paths? So the first thing is the performance testing. So the primary focus of performance testing is to measure how well an application performs under different workloads. So when I say different workloads, it can be of any workload. It can be it starts from even one single user load to 1 million user load. So your objective or your focus is to measure how well the application performs under different workloads, and this focus includes evaluating the application speed, its stability, and the ability to scale, which is, we call it as scalability. So let me give you a quick example. So let's say you're launching an e-commerce website, and the performance testing would simulate 10,000 users shopping during a flash sale, or something like Amazon Indian Festival. So that's a very easy example for you to understand. So it's a kind of an Amazon Grand Festival where Amazon is giving the shopping deals. So you would test how quickly the pages load, and how fast the transactions complete, and how the site responds under heavy traffic. So if the page load times slow down, or the site getting crashed, the performance testing or the performance tester will identify these issues so they can be fixed before going live. So that is the primary focus of the performance testers. And when it comes to the performance engineering, the primary focus of performance engineering is to optimize the entire system to ensure it can scale efficiently and perform well, and not just in tests but also during the actual use. So when I say actual use, it's in the load, it's in the production environment. And the performance engineering focuses on making sure the system is built from the ground up to perform well under real world conditions, that's in the production. So to give an example for the performance engineering primary focus, so the same e-commerce scenario, so performance engineer would optimize the database queries, he will optimize the server configurations and the code architecture while the site is being developed. So they ensure that the system can handle thousands of users on high transaction volumes without slowing down or breaking. So that is the primary focus of the performance engineers. For example, they might introduce caching mechanism to reduce database load during high traffic. And in fact, I have discussed several videos about caching as well. That's one of the way to improve the performance of the application. Under that comes under the performance engineering. So that is the primary focus of the performance engineers. That is to ensure that the system can handle thousands of users on high transaction volumes without slowing down or breaking. And like giving an example where the performance engineer will introduce some caching mechanisms to reduce the database load during high traffic. And then the third part, which is the site reliability engineering. So the primary focus of the site reliability engineers is to ensure the system remains reliable and available by using software solutions to manage operational tasks and prevent outages. So in this site reliability engineering, if you notice here, You're not testing anything. You're just checking the reliability and the availability by using the software solution, so which is like the tools. And you're also going to check the you're also going to prevent the outages, so it's a kind of a proactive job. So coming with an application, the same application which I have told you in terms of performance testing and performance engineering, the same application, you're having a e-commerce website, and an SRE team is taking care of the application, and they would set up the monitoring tools like Prometheus to track the real-time metrics, for example the CPU usage or the memory consumptions. And you can create automated systems to manage the incidents. So if a server goes down during a sales, an SRE might have an automation in place that reroutes the traffic to other servers or scales up new servers automatically to keep the site online, and that will ensure a smooth experience for users. So in this focus part, I have never mentioned about testing, right? So that's the one thing which the performance testers and the engineers do. So when you're an SRE, you're not going to test. All your job is to monitor the application for availability, monitor the application for any outages, and if you have, it will trigger an alert. And once it is triggered, you must check what is the reason or what is the issue for the outage in the production environment, and you're going to reroute the traffic. And if it is not uh, done manually, it has to be automated. It has to be automated so that you don't need to wait to complete that task manually. So that is the primary focus of the performance testers, the engineers, and the site reliability engineers. So each role's focus differs in scope. That's what I'm trying to say every time. So the performance testing is about finding the issues after development. The performance engineering is about preventing them during development, and the SRE is about maintaining reliability during live operations. So that's the three difference. That's the difference between all these three jobs. So finding the issue is what the performance tester does. Preventing them is what the performance engineering does. Maintaining the reliability during live operations is what the site reliability engineers does, and that is the primary focus of all these three jobs. And now we'll move on to the next part, which is the objective. So previously we discussed about the primary focus, and now we are going to discuss about the objective of all these three jobs, all these three um, uh, roles. So starting with the first one, the objective of the performance tester. So the objective of the performance tester is to identify the performance issues such as the speed of the web application, the scalability of the application, and the stability in the application. So this means testing the system after development to discover how it performs under different conditions and workloads. And that's why we use load testing, we do use scalability testing, and we use stress testing as well. So all these testing types were used to identify the performance issues. And take for an example, so imagine you're developing a mobile banking app, and once the development is finished, you run the performance test to simulate 1000 users logging in at the same time. So during the test, you notice the login process takes 10 seconds for most users, and some users even experience app crashes as well. So these issues like slow speed and crashes under load are identified in performance testing and allowing the team to address them before releasing the application to public. So what you do is you are testing your application after development to discover how the application performs under different conditions and workloads. And that's again the objective and the primary focus of the performance testers. And coming back to the performance engineering, what do you do? So the objective of the performance engineering is to prevent the performance issues by optimizing the system design and the architecture during development. So you do work on optimizing the system design and the architecture part. So the focus here for the performance engineers is to make sure the system is built to avoid issues like slow response times, poor scalability, and instability from the beginning or from the start of the development. So for an example, the same mobile banking application. So a performance engineer, what is his role or what is his objective in the application is he has to work alongside the developers during the coding phase. The performance testers do not do that. They get the application only after the developers give it to them. But the performance engineers, they have to work alongside them, because many times this is the question that's been asked to me, like when does the job of the performance engineer starts? It starts alongside the developers during the coding phase. For example, instead of waiting until after development to fix slow response times. The performance engineers might suggest optimizing the database queries that handle login requests. And this part, this objective part that I'm talking about, is to ensure the system can handle thousands of concurrent users logging in without delays or without any bottleneck. So that is the objective of the performance engineer. So their main focus is to, or their main objective is to prevent the performance issues like the long login times, which is seen during the testing phase. So in the previous objective, we saw about the long logging time, like which is taking less more than 10 seconds. So that part is going to be eliminated if the performance engineer does their job correctly. That is by um, optimizing the system design and the architecture when they are working alongside with the development team, and that's what they're going to do. And coming back to the site reliability engineers, what is their task or what is their objective? So they ensure that the system reliability and the scalability by implementing the operations as software. So how do they do it? So SREs, the site reliability engineers, they ensure the system continues to run smoothly in production, and they manage its performance through automation, monitoring, and operational environments. So taking for an example, again, the same mobile app banking application. So after the mobile banking application goes live, the SRE team is responsible for monitoring the application's performance in real time. So what they do for that? So they set up automated alerts to notify them in the app's response time, which is exceeding any of the users who their actions, their transactions, if it exceeds 3 seconds, or if the system crashes. For instance, if the login servers experience a sudden spike in user traffic, the SRE would have an automated system in place to scale up additional servers to handle the load. And that's one of the techniques. So that's why they use it as a temporary solution for handling the load. So they used to scale up additional resources. And also they ensure both the reliability and the scalability. So why do they need to ensure the reliability? Because they need to make sure that the app stays online. That's where the reliability comes in. And when it comes to scalability, they have to make sure that it can handle more users without slowing down. And that's the reason for the SRE to check the reliability and the scalability. And now we'll move on to the third part, which is the key activities. So far, we saw about the primary focus and the objectives, and now we'll see the key activities of the performance testers, the engineers, and the site reliability engineers. So, what is the key activities of the performance testers? So, we do load testing as a performance engineers. Where we do load testing, we do stress testing, we do spike testing, we do endurance testing, and also we do benchmarking. So, in fact, if we have not watched what are all these type of testing, I have created a video on all these, so you can watch my videos on that, like how to do a load test, how to do a stress, how to do a spike testing, endurance testing, and what is a benchmarking and why do we need benchmarking. So these tests, like whatever I have discussed with you so far, that these tests will evaluate, or these tests will help you evaluate how the application behaves under different conditions. So each of these tests had different set of objectives, and the metrics that we're going to collect, everything is different. So that is the reason we are doing all this testing, and they will evaluate how the application behave under different conditions. And when it comes to an example, so imagine you have an online ticket booking system for concert like Coldplay. So after development, a performance testing team runs different tests, right? The load testing, so where we are going to simulate normal expected traffic, say for example 1000 users buying tickets at the same time, and this is to check if the system responds efficiently under typical conditions. So that's the objective of the load testing. And when it comes to stress testing, we are pushing the system beyond its limits, like for example like 10,000 users who are simultaneously trying to book tickets, to see when the system breaks. And that's the objective of the stress testing. And when it comes to spike testing, we are going to do sudden bursts of users. When I say sudden bursts, you're going to go from 100 users to 5,000 users in just few seconds, and you're going to simulate to observe how the system handles these traffic spikes. And when it comes to endurance testing, you're going to run the system continuously, perhaps over several hours, to see if it remains stable under prolonged load. That is, 1000 users booking tickets for over 12 hours or for 8 hours. So that's what the endurance testing is. And this is to make sure how long the system remains stable, right? And then When it comes to the last one, which is the benchmarking, you're going to measure the key metrics, like, for example, the page load times or the transaction times, to compare the performance against industry standards. And that is the overall the key activities of the performance testers. And after doing all these tests, you're going to collect the results and you're going to showcase it to the um, team, to the developers, and to all the stakeholders. And moving on to the performance engineering, the key activities of the performance engineering is to focus on architectural and code level optimization along with profiling, because these activities, which whatever I'm saying, the architectural code level optimization, so these activities will ensure the system is designed and they are built to perform optimally before it reaches the testing phase. So before even it reaches the testing phase, the activities of the performance engineer starts and ends, right? So let's say you're developing a social media application, like, for example, it can be Facebook or Instagram, whatever application it is. So a performance engineer's role is to involve in development, which is early in the development before even it comes to the development coding part. So even before that, the role of performance engineer starts. And it's to make sure the system can handle millions of users who are sharing content simultaneously. Right? So we always do that. And the performance engineer has to optimize the architecture by introducing caching layers to reduce the database load, or to ensure that the data retrieval is efficient through better indexing strategies. And also at the code level, the performance engineers should identify any inefficient code paths and refactor them to reduce the response times. For example, to improve a feed generation algorithm, so it can scale to support millions of users viewing the content in real time. And then by using the profiling tools, for example, like Dynatrace or New Relic, the performance engineers has to analyze how the app uses resources like CPU, the memory, or the database queries. And also, they have to identify the potential bottlenecks to be fixed before the application is tested or before it goes live. So, that is the key activities of the performance engineers. It involves more of a kind of a code. So, he has to make his hands dirty with the code. So, he has to optimize, he has to jump in and find the architecture and code level optimizations along with profiling. So, if you're someone who wants to change your career path to performance tester to performance engineering, you have to involve in the development as well, in the architectural part. And then the last one, which is the site reliability engineering. So what is the key activity? So the centers on monitoring the alerting, alerting, automating tasks, and handling incident responses in live production environment. So the SRE focuses on keeping the system reliable and stable after it is deployed. Okay. So coming back to the example, suppose your social media app that you have launched and it is going live with millions of active users. The SRE team is responsible for making sure the system stays up and the performance and performs reliably. And when it comes to monitoring, the SRE tools, the SRE should use tools like Prometheus or Grafana to monitor the metrics like CPU server, the server CPU usage, memory consumption, and the API resource response times in real time. So that is the uh, key activity of site reliability engineer in terms of monitoring. And also he has to set up the alerting as well. So he has to set up automated alerts to notify the team if the app experiences slowdowns or any downtime or any resource overconsumption. So for instance, if the CPU usage exceeds 80%, an alert is triggered to check for potential issues. And then the automation of tasks. So the SREs has to automate every single task that are doing on daily basis, because that will help them to make their improve the efficiency of their tasks. So they have to automate the scaling so that when the traffic spikes, for example, during any major events on the app, so the new servers are automatically spun up to handle the load rather than they are manually spinning up. So they have to set up an condition where if the CPU usage goes beyond 80%, they have to spin up another, they have to scale up, or they cannot scale up, but they can scale out. So in fact, I have discussed about what is scale up and scale out in one of the video. You can even watch that. So this is to make sure that the application remains available. And then finally, the incident response. So if a server crashes, so what the SRE does? So the SRE should handle the incident response, right? And they have procedures in place to quickly identify and fix the issue, whether by restarting the services or by rerouting the traffic or by patching the faulty code, and to minimize the downtime. So just to give quick summary of these three differences, the key activities. So the performance testers focuses on testing the application's performance under various simulated conditions like load, stress, endurance, etc. after development. And the example is to run the test to see how a concert ticketing system handles thousands of users who are trying to book tickets simultaneously. And when it comes to performance engineering, it involves optimizing the system's architecture and code during development to ensure it can scale and perform well. For example, optimizing a social media app's architecture by adding caching and efficient database queries to handle millions and millions of users. So that's the performance engineering's key activity relies on it. When it comes to the activities of site reliability engineers, they have to focus on maintaining the system reliability and the performance in production through monitoring, alerting, and automating operational tasks. For example, monitoring and scaling a live social media app to ensure servers can handle increased traffic during a viral event. And now we will move on to the last topic of the day, which is the approach. So, how do the performance testers or the engineers or the site reliability engineers approach their actions? So now we'll look at the last difference of this day, of this part. So in fact, we have like two more different parts because there are like lots of information to be shared. So in this one, we'll see the approach part. So when it comes to approach, what's the difference? So when I say about the performance testers, they are reactive. So why reactive? Because the performance testers focuses on testing the application's performance after the development has been completed. So they have nothing to do before the development. They have all their activities only after the development, and this actually identifies, I mean, this part of testing is to identify the issues that exist post development, and also it will help them help everybody to fix or help the developers to fix them before the system goes live, right? So as I say, the approach is reactive, which is that they react only after the issue comes up, right? And they do testing, but yeah, they do testing to find what is the issue, and then after that they find the issue, they are used to fix that. And then when it comes to an example, so imagine you're developing a video streaming application, something like a Netflix or Amazon Prime or Sky TV, or name whatever application you're working on it. So after the development team finishes building the application, the performance testers or the performance testing team should test how it handles high traffic during a live stream. So they simulate thousands of users watching a live sports event. So if they find the app slows down or it buffers frequently, they reactively address these issues by adjusting the server capacity or optimizing the streaming algorithm after development. So that's what the performance testers has in their hands, so that they are reactive, right? So they can do only this much amount of actions. But when it comes to performance engineering, they are proactive. So that's the difference between the performance testers and engineers. The performance testers are reactive and the performance engineers are proactive because they focuses on integrating the performance optimization throughout the development process. So it involves designing and building the system in a way that prevents performance issues from occurring in the first place. So, for an example, the same video streaming app. So, performance engineer should work closely with the development team to ensure that the app's architecture can handle millions and millions of concurrent users without buffering. For example, they might optimize the way the video is encoded, because encoding is also another way where you can optimize the optimize the video, or also they can implement any efficient load balancing across the servers to prevent bottlenecks. So again, I have discussed about what is load balancing in another separate video. If you haven't watched it, please do watch the video. So by addressing the potential issues before they occur, they ensure the app is ready for large scale events like a global sports final, for a football final, or for any like cricket IPL. We all know about the IPL, right? So in fact, in several scenarios we face that issues, like during, I think I remember for one of the IPL match there were some issues where during with the streaming platforms. So these are all the issues which can be proactively fixed if the performance engineers know where to fix it from the very beginning. Okay. And then coming to the site reliability engineers. So they are not proactive or they are not reactive. They are a continuous improver. So they do continuous improvement. They focus on constantly improving the system's reliability and the performance by automating tasks and resolving issues while the system is live in production, because these SRE continuously monitors and adjusts the system to ensure it remains stable and scalable in real time. For example, once the video streaming app is live, the SRE team sets up real-time monitoring to track their server health, or to track the video streaming quality and user load. Because during a high traffic event, for example, like I said, the IPL matches, if the server starts lagging due to high demand, the SRE would have automation in place to automatically scale up additional servers to handle the increased load. Because if the server fails, the SRE uses incident response times to fix it with minimal downtime. And they also analyze the data post event to continuously improve the system's resilience over future events. And by doing this, they are able to avoid these issues, and this happens in continuous improvement. They does not have like what the performance testers does or the performance engineer does. This comes in a continuous improvement process. So with that, I come to the end of this video, and I believe this video will be very useful to you. So until I meet you in our next video, it's bye bye from Asan Shanmugam and your favorite little star YouTube channel. Take care and bye bye.